Hello everyone, and welcome to this video where I'll be taking you through a sample question on the objective, write the parametric equation or equations of a curve. In this video, I'm going to be going through a question from Knewton.com's Knewton Alta homework system that's related to this particular objective. And I'm hoping that watching me do this here will help you when you come across similar questions related to this objective when you're working on Knewton Alta yourself. And of course, when I come across the question, when I bring it up, I'd suggest if you already have a familiarity with the material, pause the video, try to work it out yourself first, and then come back, watch me do it and see how your work compares to mine and how you're faring. Okay. So here we are at Knewton.com. I'm in the instructor mode, just a view of some questions you'll come across when working on Knewton Alta. And we're in this objective, right, the parametric equation of a curve. And here's the first one, and all the rest that you'll come across in this same objective will be very, very similar to this one. So here we're asked to determine a pair of equations that can parameterize the curve negative 7x to the fourth equals negative x minus 4y plus 7 using x of t equals t minus 6 as one of the equations. All right, so they're already giving us an equation for the x coordinate of any location that depends on a parameter called t. So all we need to do now is basically substitute this t minus 6 for x in the equation for the curve and solve for y. And then we'll have our y coordinate of any location as a function of this same parameter t. So let's do that. All right, so here was the equation of the curve without the parameter, right? Without this p parameter that x and y depend on. So it was negative 7 times x to the fourth equals, and negative x, or the opposite of x, minus 4y plus 7. And we're given the following, right? We're given x of t is t minus 6. And we're asked to find, parameterization for the y coordinates as well, right? So find y of t if this is our parameterization for the x coordinates of any location on this curve. So like I said, we can do one of two ways. We can substitute t minus 6 in for x now and then solve for y. Or I'm going to do this because I feel like it'll take less writing. I'm going to solve for y first, right? Since we already have the x equation, I'm going to solve for y first and then replace the x's with the quantity t minus 6. That's all right what I'm doing. Solve for y. So I'm just going to take, because I prefer having a positive coefficient on a term with things I'm solving for, right? This is a linear equation in y, right? You have y to the first power. So I'm going to take everything. I'm going to add 4y to the left, and then add this 7x to the fourth to the right. So I'll have positive 7x to the fourth, and then the minus x and the plus 7 I didn't do anything with. and then multiply both sides by 1/4, right? Or divide everything by 4. So y equals 7/4 times x to the fourth minus, 1/4 times x plus 7/4. Okay, so I've solved for y. So that's another equation for the curve, and I didn't divide by anything with variables or anything like that. So when I type, I'll go to desmos.com in a minute. You'll see that if I type this in or type the original in, they'll be showing you the same curve on the XY plane. And now for the parameterization of the y coordinates, right? I'll take my parameterization of the x coordinates. X of t is t minus 6, and substitute for x in this equation here, and then we'll get our y coordinate in terms of this same parameter called t. So after substituting, we have y of t equals 7/4 times, and then replacing x with t minus 6. So you have the quantity t minus 6 to the fourth power minus, and then here's 1/4 times, again, x being replaced by the quantity t minus 6. And then there's, the constant there, plus 7/4, and here we go. Gonna box this in. This is all we were asked to do. Now I'm going to show you a little more, of course. Put the curve up in Desmos, but this is all I would have to type in the blank in Knewton Alta. And there, we have our x coordinate in terms of p, and the y coordinate of any location in terms of this parameter p as well. So yeah, in this blank, right, where it says y of t equals, that's what I would type in. And I'm in instructor mode here. We can see the answer. See this 7/4 times the t minus 6 to the fourth minus, and then 1/4 times t minus 6, or t minus 6 over 4, and then plus 7/4. Exactly what I wrote. All right, now if we'd really like to double check and hammer it home, like I said, I'm going to go to Desmos, right? This is desmos.com, free online graphing calculator site. And let's take a look at the curve, the equation of the curve they gave us initially, right? We had -7 x to the fourth power equals -x, or the opposite of x, minus 4y plus 7. All right, so here's what this thing looks like, right? They got a couple points plotted. Here's 0 and 1 3/4, and whatever that is. All right, that's looks like the bottom of a valley, right? A local minimum. But yeah, there's part of the curve here in red, or whatever color you see. Again, I could have also solved, earlier I solved for y and whatnot, but let's just leave it the way they gave us. All right, so now I'm going to put in our parametric equations. Right? We'll have x and y, both depend on this parameter t, and we'll see how it will trace out this same curve that we're looking at right now. So to put in parametric equations in Desmos, you have to enter it as an ordered pair. So left parentheses, and then the x coordinate in terms of t is, that was given to us as t minus 6. Right, so I'll type that. Then a comma, and then the y coordinate in terms of t, and that's the thing I found on paper. The 7/4 times the quantity t minus 6 to the fourth minus 1/4 times the quantity t minus 6, and then finally plus 7/4, right? And then close the parentheses. And now at the moment, it has the value of t ranging between 0 and 1, right? And when when t equals 0, the x coordinate is -6, so we got to go over here to see that point show up. Quite a ways. Like, I don't want to go through all that, but we're not seeing it in the main screen here, but it's there. If I want to see some stuff on this part of the curve here, notice, these have x values from, well, let's just say I wanted the x values from -1 to 1, all those points to show up. I'd have to plug in, 5 for t to get an x value of -1 and 7 for t to get an x value of +1. So let me change this range of t here from 5 to 7. And then did you see the blue thing just show up? All right, let me turn this red off, right? Those blue points are clearly on the curve, the red curve, right? But they're only the part of the curve where t goes from 5 to 7. And if you'd like to see more, right, you just kind of change this up. I'm going to have it be centered at 6, right, where the x coordinate 0. So, I mean, I could go from like 0 to 0 to 12, and you'll get a bunch of the curve, right? And again, very clearly tracing out the same curve. All right. Great. So the parametric equations I came up with are correct. They do trace out that same curve that we were initially given with just x and y involved. All right, you just have to plug in the correct values. You just plug in different values of the parameter, trace out different parts of the curve. Wonderful. And that's it for that. Again, this question here, very similar to all the questions you may come across related to this particular objective. So I hope watching me do this one helps you out when you're working on it on your own. And thank you very much for watching.